Hi everyone. For those of you that do not read the beginning of well, all the descriptions for all the videos, I know I wouldn't. Just letting you know why the last MFC video is optional. It's not optional in the real optional way. It's the me going through MFC, making an application. If you need the help with it, watch the video. If you don't need the help for it, don't watch the video. It's all I'm going through code. Now, the reason it's optional really is because it's not this well-oiled machine. It's me improvising some kind of application I'm dealing with. And I hit intentionally, well, one part was intentionally with the checkbox. The other part was not intentionally when I hit a little snag. And you'll see me actually go through and debug how, or reason through my code and how things are going wrong, why they're going wrong. We eventually get the fix in there as a result. But it's a little bit of it is not a clear linear path, because debugging things is not a clear linear path most of the time. So I like showing where things go off the rails. I know if you don't like that sort of thing, don't watch the video, because it does go a little bit off the rails at one point. It's fine in my books, but maybe you don't like that. Ironically, perhaps, I don't think I've ever once given that demo without something slightly going off the rails. There's just so much, I don't know, stuff in there where it's doing the code for you. It makes me quite uncomfortable. Speaking ironically, because when we're talking about model view controllers now, I'm going to be giving you guys a whole lot of code. The difference is it's not hidden away code with a whole bunch of weird names for everything. The code I'm going to be supplying you should have comments all over the place, and we're going to talk about it and talk through it right now, like today. Okay, so we're going to look at the separation of concerns for a graphical user interface. The reason we do this is because I have tried repeatedly in my youth, I guess. You'd be, oh yeah, what does everyone else know? All right, I'm going to not do this separation of concern. It's going to take too long. It's just a quick little application. Don't need to worry about that. And almost every single time I do this, it sort of comes back to haunt me. The idea here is that if you do not have control of your program from start to finish, if you're waiting for events to come back, you need to defensively program things. You cannot just assume things are going to work in a particular order, and therefore you need to make sure that your code is able to handle weird cases. And so the model view controller approach, as soon as it gets invented, everyone goes, yeah, that's what I needed. The reason you need it is because if you do not separate out your different concerns, it becomes an impossible task trying to get your head around what your code is actually doing. If your painting of your code is happening at the exact same time as you're changing the underlying data, if I'm able to draw something on the screen, and by the act of drawing it on the screen, it's also manipulating the data, the model that it's using, that's a terrible situation, because now suddenly I have to worry about the speed in which I'm rendering things, how many frames a second I have for my video game, for example. I need to worry about if I draw this so many times, will it change the data? Will I accidentally have something in a transitory period? So I start drawing it one way, the data changes midway through me drawing something, and then everything else changes afterwards, right? Weird bugs pop up. So the idea is I want to separate these three ideas when it comes to my code. I want to separate these three ideas out. The nice side effect of this is I can do all sorts of cool things once I have a model view controller architecture. So this would be things like everyone's using the same Google document, and each of us have our own view of the Google document, and each of us controls the Google document. But the Google document, the data that you're looking at, the actual document, is the same for all users. That's sort of the mental model to keep in mind, that multiple people can have different views of the same document, control it at the same time. Or maybe I have one controller and everyone has to use it, but you have multiple views. Or maybe you all have the same view, but everyone has a controller. You can do all sorts of weird, crazy things once you have this kind of approach. So let's dive into it. So what normally we have with the GUI is we have a bunch of looks. Right? How does it look on the screen? Whether it's a Mac or a Windows machine, it looks differently, right? How do we interact with it? Am I using a mouse? Am I using a pen? am I using my finger? All three, oh, there we go. That shows that. That was me using my finger. Here's me using a pen. Here is me using a mouse. All three controllers at the same time, or almost at the same time. I can also use my keyboard. I have all of these ways of interacting with the system. Heck, you can imagine touching it or using your eyes to control with an eye tracker. I don't want to limit to that, and I also don't want to have to make a whole new application if someone uses a trackball instead of a mouse, right? I just want the controller to be doing something a different way. I like to abstract away that idea. And then I have this sort of back-end idea, what the data looks like. And you may have seen this in other applications, but ultimately the user does not give two craps about that back. They don't see it. They do not see what the data looks like. They see what's on the screen. They move their mouse. Right? They're interacting. They have an input. They have an output. So an input. They have an output. They don't see what this thing is at all. This is sort of a side effect of this thing. So what we have is we see something, we used something, we don't care about this thing. Well, we don't directly influence it, but it's important. So the interactions, if I have an interaction component, it then hooks up and manipulates and changes the back end. So when I push this button, it changes how the button looks, or it changes what's shown on the button. And then I can go one further, and then the back end will update the look. So I click the button, there's a message that gets sent to this object, the button object, and says, hey, by the way, you've been clicked. The back end says, oh, I've been clicked, I better change my state. Then the look says, oh, we've changed your state, I better change how I look. And then you get that sort of depressed looking button instead. And as soon as that goes away, after a certain amount of time, the back end says, hey, my state's changed again. I'm back to being non-pressed anymore. And the look changes itself again. I don't want all in one package, because if it's all in one package, I can't tease these ideas apart. So this is our idea of a model view controller. I will get to it later, but I'll just give you an advance warning. They're never as simple as they seem, but this is the theoretical underpinning, that my views can talk to the model, my controllers can talk to the model, they can talk to each other, so the model can say, hey, controller, you're turned off. Maybe, maybe not. The model can also tell the view, or the view can also tell the model, by the way, the finger was over this point if there's some kind of bit mapping thing going on. They can technically talk back as well, depending on how I want to implement this thing. I can have the view and the controller talk to each other if I wanted to. Again, depends on how I implement this thing. But ultimately, I just want to say these things are different ideas. I separate them out. So what the data looks like, what the object looks like, the stuff I'm storing, like the text that's in a text box. It's part of the model. How it gets displayed on the screen is different. The view will say, hey, what's the text you're displaying? Now let me draw it properly. The controller lets you click, or you type it in the keyboard, and that keystroke will then go to the model, and then the model will be updated. They're separated concerns. We do this all the time. This is what a client-server architecture looks like if you were doing anything like that. I have, let's say, my bank account. If I'm doing online banking, I go to make it, this is sort of a theoretical underpinning, I guess. If I'm making a deposit, I am typing in I'm manipulating, I'm clicking something to press send to deposit some amount of money. That then goes off to the bank account gets updated, and then what displays on my balance is sent back over to the client. A client-server architecture actually there's a wire between them. The bank account, the model here, is on a different machine. It's in a secure location. What I'm seeing on the screen and how I'm interacting with that screen, that's on the client side. And this is on a completely different machine, and it works as a result. What I don't want is to be directly manipulating something I shouldn't have to go into some bank vault to do my banking. And in case you think this is only for, this sort of thing, Pretty much every single game development, or at least in the olden days, back when dinosaurs roamed the earth and I was a programmer, um, for GUI development, for if you're talking game development, sorry, I should say for game development, GUI development is like you're making buttons and click things that you click. App development, same thing. There's a front end, there's a model view controller for every single Android application, and there's a model view controller for every single, iOS application. For game developers, it was effectively the same thing. The default, or the conventional approach to game development, and it may have modified a little bit since then, but not that much, is that you have an intentionally infinite loop, and all your game does until you have an escape or a leave message that gets posted, all your game does, honest to God, because I've done this numerous times, you have an infinite while loop that goes on for infinity until you actually intentionally escape your program. And all you do is get something from actions from the user, like mouse and keyboard events, and pass them along. Then you update what's on the screen, update what the state of everything is, and then you draw everything. 3 completely different things. They're not really and you treat them separately. So, for example, I might be playing Mario. Okay, so the user presses a button for Mario to jump. Okay, Mario gets a message saying you are going to jump. Every single time I get an update, the progression in the animation of Mario jumping changes a little bit each time. Also, the flowers in the world start swaying a little bit each and every time. Every time there's an update call, these things move it a little tiny bit. I just change the position where the flowers, or what it actually should say, what image in a series of images that make up the flower animation, what image in that frame, in that series of images am I in? If I'm jumping on top of an enemy, it's checking to see if Mario is in contact with me. If Mario is in contact with me on top of me, then I'm going to be squished, right? And I go through the animations for squishing that particular enemy. They're not the user. The user's not doing anything there. It is Mario, the character, jumping on top of me? And what stage of my animation am I in? Completely different than actually drawing the picture. You're just saying, I'm on frame 4, I'm on frame 5, I'm on frame 6, I'm going to transition to dead Koopa. That's what update will do. And as soon as it's dead Koopa and I'm on frame 4, I'm painting frame 4 of the dead Koopa set of images. The painting is completely separate from where I am in the game. So that if the painting takes longer than you'd expect, the updating, you can bail out on this thing, the updating will still work. Things are timed correctly. They're not based on how fast you can paint things. You can imagine if I drop the frame rate, the timing for everything should still be the same. So if I'm painting at 60 frames a second, I'm going to draw the images on the screen 60 times per second. Everything. I'm just drawing everything. I may not be updating the data that fast, or maybe I'm updating it even faster. Again, a separation of concerns. That's what I want with this thing here too. I want to be able to draw 60 times a second and not have to get information or update the bank account information 60 times a second. It separates what my concerns are. So again, client-server architectures are this. If I have JavaScript and HTML on my end of things, I'm drawing stuff on the screen. I'm getting user input, user actions. So the sort of part of the controller. The drawing is HTML. It's rendering everything, and the model can be something like JSON data, whatever the case is. It's often on the server side of things. You are sending in a put request to change what's on the back end. So the user does something, it then sends a message to update things on the back end, and eventually that gets sent back over, and this gets up, the image gets updated. Again, separation of concerns, because I don't want to have, so that means I don't have to, when I click something and I can keep on working on, like I go to, I change some values, a message goes off to the server, the data doesn't get updated until a message comes back, but I can go off and do other things while I'm waiting for the server to get back to me. The model itself, though, is where you want the one-stop shop normally for all of your data involving your object. Do I need to know if it's been clicked? Do I need to know if it's the color blue? Do I need to know how many images I have? Do I need, like, things like that? The view only paints. It only draws stuff. It should not manipulate or change anything. The controller, on the other hand, deals with user input, and it's only pretty much callback events. Every time I get a callback event, it's some kind of controller thing. The components talk to each other, but they change depending on how you want to design it, and only as necessary. They're not constantly chatting. They're just, when the view needs something about the model, it gets it. I said this is like the Holy Trinity kind of idea, right? There's three different things acting as one. So they're actually three different classes, but you pretend they're one. So instead of, and when I was working at Google Play Newsstand, or what's called now Google News, is it Newsstand? News? Anyways, when I was working at Google, we had this, and it wasn't even that, it was kind of frustrating, weird and roundabout. They had
Sorry, I don't understand.
I don't know why it keeps on answering like that. It had triplicates of everything. There was a whole set of all the different shapes, objects, things in the system for views, a whole set for the controllers, a whole different set for the models. Everything was triplicated, essentially, but you pretended it was one thing for each component. It is a crazy amount of extra work. It's an upfront cost for long-term savings, because if you don't do it this way, you will cry. You will. It always comes back to haunt you. So it is to save your sanity, because if you have to worry about when I'm changing the data at the same time as drawing, you are in a bad situation, right? I want to separate out these things. I don't want to be writing an assignment at the same time as I'm writing an exam, right? I want to work on one class and then I want to work on another class. I don't try and mix these things up. So if you want to think of it, if anyone knows what Voltron is, it's like Voltron. Voltron is one giant robot, but it's actually 5 lines that all connect together. And they also have a sword, which is pretty cool. Here's another example, rather than Voltron. The selection pane. This is a 3-state button. When I hover over it, it changes the state. It gets gray. When I click it, you get this this animation effect where it looks like it's being compressed and it comes back up. But if I compress it and keep it down, it looks like it stays compressed. So on a mouse down, it goes down. On a mouse up event, when I lift up the mouse button, it pops back up. Try it out. Try any of your components on your system and click it. Move your mouse over top of it, see if it changes, and then move it on top of, and then click down on one of these buttons and see what happens. It's this 3-state button. What I don't want is to have to worry about what state I'm in, what kind of mouse event I'm getting at the same time as I'm drawing this thing. I want to blindly draw it, because I may have a lag, or maybe I want to stop people from clicking something, but I don't want to have that logic in how it's being drawn. I don't want to have to, I sort of really want to separate how all of these things work. So here's a 3-state button. One way I could have done it. I'd have the user moves the mouse over top of something. When they move the mouse over top of something, I get a mouse event. The mouse event says the mouse is on top of me. I ask the model, hey model, what is the mouse on top of the region where the button is defined? It says yes. Okay. Then I send back and say, but now I'm going to set you as hovered over or highlighted for being, selected on top of, like the mouse is on top of it. is mouse on top. Set is mouse on top to true. The model says, okay, my state has now changed, and then it will tell the view, hey, you have to redraw yourself eventually. The view then, says, okay, I need to redraw myself. It gets what's called a redraw event, a redraw call. When it gets a redraw call, it says, okay, I got to redraw myself. Hey, model, are you selected? And the model says, yes, I am. Okay, if the model's selected, then I'm going to draw it with a gray box. The benefit of this here is if I move...
I found these results.
Oh my God, why will it stop? It gotta stop. My phone is going off for everything. If I move my mouse over top of the 3 state button really, really, really fast, if the view cannot keep up with it, let's say it's a slow system, I'd be changing the state for hovered over, I guess hover over might be the better state, hover over to on, off really quickly. If the view can't keep up, it doesn't matter. If the view can't keep up, great. If it can't, fine. So what you don't want is if I don't know if you've seen any of those terrible old systems where if you move the mouse over top of something, nothing would happen, and then suddenly you get like 40 different changes afterwards. If you separate your concerns, you don't get that effect. Okay, so the controller goes to the model then tells the view, hey, change. The view has no idea what how the button is selected. Does it use a finger? Does it use a mouse? Does it use a keyboard? You don't care. That's the point. The view doesn't know how the state of the button, what state the button is in. It finds out. And the view doesn't know what the color background is, which we'll look at when it comes to our code. It doesn't need to know. It doesn't want to know. That's part of the model. It can ask for what the color is, but it has no need to know what the color of the background is. It doesn't need to know what frame of the animation it's in. It can get that from the model. So if the model has a whole bunch of frames of animation and it's cycling between those frames of animation, all the view needs to do is say, hey, what image am I drawing? This one. Okay, I'm going to draw it, and it just blindly draws. Something else controls the state. It just blindly draws. The controller doesn't worry about what color the button is. The controller doesn't worry about it doesn't worry about mouse event keyboard. The model doesn't worry about mouse event keyboard events and painting. I was wondering why that was the case, right? It doesn't care how many times a second the paint event is called. It doesn't care if you're showing this thing at 60 times a second or 30 times a second. It doesn't change the model. And one of the big rules I want to make sure that we're very clear on, you never, ever, ever change the model while painting. I will get people doing all sorts of crazy stuff with this. Not so much with this class, but every time I teach an HCI class, I get this, where they try and keep track and they hold on to the last bitmap when it happens. So when a paint event happens, they keep it. When they get a mouse event, they then stomp on the bitmap and they directly change things when a mouse event occurs. And then you resize the image, and suddenly their entire thing goes away. They didn't have a model, they didn't have something stored for how things should be drawn, and while they're stomping on it during a mouse event, the moment you resize the window, you would lose the entire bitmap, everything goes away. So, it's the only way to keep your sanity, honestly. So, for assignment 5B, and I may have said 4B and 4A, I meant it's supposed to be 5. Assignment 4 is that media library thing. What we're going to do is we're going to refactor a shape program. So we have 3 different shapes. I've already refactored one of them, or I'm going to do it live in front of you guys very, very soon. And so what we're going to refactor it so it performs a model view controller approach. And technically, you could put all 3 classes in the same file. That's what I'm going to do for the triangle class and what I did for shape 2400. Or you can make 3 different files. That's fine. Probably easier to do it all in one file. You should need very little code, but you're going to be moving lots of code. And when you move code, you may have to do little tweaks afterwards. It's a little bit scary, but hopefully we'll make it so that it's not as scary as it could be. Do one little change at a time, make sure it works, move on. That's what we're looking for, little bit at a time. The view and the controller will need to know about the model, and so you'll need pointers. The view and the controllers will always keep on needing a pointer back to the model. And I want you to think before you start refactoring. Don't just randomly just pull out code and start moving crap around and hope for the best. Think about what your plan is. You might get into trouble along the way, but that's fine. Just take a deep breath and go back and figure out what went wrong. If you just blindly go, moving around code and hoping for the best, it's going to be really bad because you're not going to know why it didn't work. So think before you act. Okay. And again, one of the big things to remind you of is that MVC architectures are never that simple. So Java has a controller and then a model view. So the model and the view are wrapped together and the controller is separated. Android has a model view, model controller. Because when you rotate the screen, it destroys everything. And it was such a pain in the bum that they actually developed a new way of doing MVC as a result. It is what it is. You work around what your use cases are. You work around what your task, your code needs to do. But the model view controller is a sort of generic, high-level description of what we're doing, separating out our different concerns. It does have, the particular design pattern does require extra code. It requires extra layers of abstraction. So this gives us an extra layer of abstraction so that we don't have to worry about one affecting the other. And every time, as I said, every time I don't follow this, I have a bad time. So I also was thinking about this. The analogy I like is a restaurant. So if you go to a restaurant, or especially if you watch the movie Ratatouille, good solid movie, you have a separation of concerns there too, right? The saucier, the person who makes sauces, they make sauces all day. There's a person that makes desserts. That's all they do. Pâtisserie. They make desserts all day. We have different specializations for the cooks. We have the chef who's actually overseeing everything else, right? They're supposed to be more general. They have a sous chef, which is their second in command. We have the plongeur, who is the guy that mops. So we have someone like the chef. We have someone like the waiter. The waiter is not cooking in the kitchen. They're presenting things. They may help clean up the plate. They're offering wine suggestions. They don't go and break out the creme brulee torch. And the plongeur is the one who ruins the soup, and then the rat has to fix everything. That's a different stretch of things, right? You should not be letting just random people cook. The person that knows how to cook cooks. Not everyone's going to be doing that. Okay. So we're going to refactor MVCCANVAS. I'm going to try and do this live. So reminders for me, I want to demo it first, just show you what's going on. I want to show you how events actually work. I want to talk about the canvas object itself, which is an object that I made for this particular application to try and make it easier to get your head around things. And then I want to show you the shape factory, which is deals with the canvas object. It's a design recipe or a design pattern that we use. And then I want to talk about shape 2400, rect 2400, triangle 2400. These are our different shapes. A generic shape that you shouldn't be able to draw, a rectangular shape, and a triangular shape. We've seen a demo of this before, but the demo is going to be a little bit different this time around. Okay, so there you go. Let's make sure I'm actually recording still. Yeah, there you go. So let's pull up, here is our shape 2400. Let's go into here. By the way, this is a design pattern in case you're unaware of it. One of the design patterns you could have, one way to deal with the sheer stupid number of include statements that you have in one of your programs, is just throw them all into one header file, like here, frameworks, windows.h, this, all this, right? Every single header file that we're going to use is stuffed into this one .h file. So each and every one of my A3 shapes W20, for example, circle 2400, line 2400, they all just include that one file. And the first person to get it includes every single header file. So that is one little workaround that you can do, so you don't have to worry about, you put all your major constants in here, you put all your includes in here, so it's a one-stop place for all of your information involving shape 2400. Okay, or these shape classes. Should say to do for me, and I'm going to pretend that I didn't write that part. Okay, so we're going to migrate the classes code. This is what we're going to be doing now. This is assignment 5B. Your job is to modify the given assignment, refactoring code. I'll make sure I update any of the comments here beforehand. I've been reusing this code and modifying it in various ways over the time. But here is our traditional Windows drawing program. So I have, this is all pre-canned code involving the title, for example, the instance of this particular window. We talked about this last time. I have an initialize the instance of this particular window. So when I start things up, this is when I'm processing various messages as they come in. This is the bread and butter. This is the big one you have to look at. Not the about, not an instance or anything like that. This is the function that you're going to be looking at. And here is my MVCCANVAS, this generic catch-all. It handles everything about the entire application. It's just a giant white canvas. It handles all the particular mouse events. It handles all the keyboard events. It handles drawing things on the screen. It handles all the different shapes, how I make a new shape, everything all in one class. So I don't have to worry about, so if I move this over to using Qt to draw everything, most of my code doesn't change. Only this one file I'm dealing with right now has to change. Okay, here's me loading strings. This is all pre-canned code. I don't think I even need to do I didn't need to write any of this stuff at all. Here's me registering things. Again, didn't need to do any of that myself at all. It's all pre-canned. I show the window, I update the window, fine. Here are some of the things I need to do. On a mouse move, I ask the canvas, I say, hey canvas, handle the mouse event. If this, so I can make it simpler for you guys to read. If this is true, so as in if this thing returns true, then I'm going to invalidate. So something happened with the mouse event. Some of the mouse event happened. I'm going to invalidate the entire screen, and so everything gets redrawn again. That's it. So this is redraw everything. Here's me out my Windows processing. I have a bunch of different commands. Like if I put the about window, exit, for example, this is closing off everything. Again, I didn't write that. Here's the stuff I did write. If the mouse goes down, the left mouse button comes up, or the mouse is moved, I check what happens when I move the mouse. That's a function in here. If I'm painting, I do the following. I begin painting. This is a Windows specific thing. I say, by the way, I'm about to start painting, and I will get a handle to a device context. This is a handle to the big image that I'm going to draw stuff onto. And then I say, hey, canvas, paint all your images onto this thing. So paint everything onto the big image that you have. That's it. And then I end my painting. I release the device context, because if I don't, I'm holding on to this big bitmap. Excuse me. I release my device context, I end my painting program, and then it draws stuff on the screen, whatever I drew onto this device context. So imagine me having a piece of paper, me turning my back to you, drawing on the piece of paper, and then showing it in front of you. So the drawing is not done right in front of you, it's drawn back here, and then I put it in front of you. Here's me quitting here, and there's my about message. That's it. This is all the Windows related stuff. You don't need to touch it at all, by the way. Everything is done in the canvas. So let's go MVC Canvas. Let's look at the MVCCANVAS.h first. So the MVC Canvas class is, we're going to refactor this right now. So we have a model view. We want to do a model view controller. So what I want to do, the idea is I want to separate. I have, instead of MVC Canvas being one class, I want it to be 3 classes, and no one's the wiser that I have 3 different classes. So I'm going to also change the other, our main, the A3 shapes class as well. So MVC Canvas is going to be made into 3 different classes. It will be a class for the model, what data is being stored. It'll be a class for how we draw stuff on the screen, and it will be a class for the all the control, the mouse control stuff. Okay, so let's go through one little part of this. So here we go. I have a limited number of shapes. That's fine. I'm going to have to change this thing as well, because I'm going to have a whole bunch of shapes, views, and controllers. Or models, views, and controllers. I should be more specific. Okay, that's going to be something for the controller, where we start and where we end. But most of the stuff will stay in the model. I can set the size of the particular bound, the size of the canvas I'm dealing with. I can add a shape, which makes sense. I can clear all the shapes. I don't think I ever call this ever once, but why not? I can. I can get the number of shapes. I can get a particular shape based on an index. It's kind of useful, or can be useful. And I can set the mouse start and the mouse endpoint. So I'm passing mouse information to the model, essentially. And I can get the mouse information from the model. I can paint the back buffer. So everything that says the word paint, I'm going to be putting this in my view. Everything that normally talks about mouse events, I'm going to be putting that in my controller. And although this talks about the mouse, it's really about the model, what's being stored. So on mouse event is in the controller. All the paint methods are going to be in the view. And I think that's everything. Okay. When I make, see canvas, when I make a new shape, here's add shape. I have a start point, I have an end point. So defining 2 points in a region. If I take those 2 points in 2 points on the canvas, that will uniquely define either a circle, a triangle, or a rectangle, or identify it well enough. So the bound of the triangle, rectangle, or circle will be based on these 2 points. Okay, so I'm going to add a shape, but this is where things get a little weird. If I need to know the exact kind of shape I'm drawing, what I don't want my canvas to know what types of shapes I have available to me. I don't want to have special cases like, oh, well, it's actually a rectangle this time, so I'm going to have special code here. What I want is to just essentially just make a shape. And I don't know what kind of shape I have. It just rolls off the assembly line. It's some kind of shape, rolls off the assembly line, and I take it and I use it and I put that shape in my array of shapes that I'm going to be drawing. It's just a big array of shapes I'm drawing. And then later on, I'm going to blindly draw all those shapes. But I don't want to have my canvas class to know what kind of shape I'm making. That should be decided by someone else or somewhere else. That's where the factory classes come in. A factory class says, you pass me in this information, I will make something for you. Ideally, you don't know what the heck it's doing. Some magic occurs and something pops out the other end. So you pull the crank and then you hear a bunch of whistle noises and stuff like that, and then a car pops off the assembly line. Right? It's something that manufactures new objects for you, and you're blissfully unaware of how it's choosing what object to draw or to make. So the factory class just makes shapes for you. It's also going to not just make shapes, it's going to make shapes, views, and controllers for you. That's what we're going to be doing. And then we're going to blindly draw the shapes, or draw the views. We're going to blindly deal with the controllers, and we're going to blindly deal with the models. Okay. So that's the approach that we're trying to take here. Let's see. Do I need, what else do I need? Clear shapes. That's fine. To paint the back buffer, it's just drawing each of the views blindly. Okay. Paint the various images. It's going to be painting the back buffer, by the way, in case it's to remove a flicker effect that we get. And then we have to see if something intersects. Okay, and on mouse event. Okay. You don't have to change any of that code, by the way. You're going to be moving it around. On mouse event will be in the controller. I'm just going to move it around. The painting is just going to be in the view. I'm just going to move it around. That's all refactoring is. The code doesn't change, it just moves. So if in case you wanted to see this in action, hopefully it's going to work. It was compiled perfectly fine beforehand. It's going to look a little weird. The triangles are not going to look right. And we'll see why the triangles are not going to look right in a second. Circles work just fine. Great. I can move it around like last time. So dot to dot. Those 2 points define where my rectangle is going to be drawn and how big my rectangle is going to be. When I have a mouse up event, it makes the rectangle for me and it puts it in my list of rectangles to be drawn. When I move the mouse, I update the state of all of my different shapes when the mouse moves. And when the mouse is over top of one of these shapes, the state of my model changes, and then I have to redraw all the shapes again. That's what's happening. Every time my mouse moves, I check to see if I'm hovering over one of these shapes or if something has changed. And if anything has changed, I request a complete redraw of everything, and the view redraws itself. Redraw. Redraw, 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 redraw. Okay. Here's the weird thing. This is should be a triangle. It ain't a triangle. On purpose. Okay. Because when we refactor this thing, what we're going to get at the end is only the triangle is going to be drawn correctly, and the rectangle and the circle are going to be looking like these gray blocks. The reason is I wanted to keep the code in a stable state that you can actually keep trying and modify a little bit and then see what happens. And as a result, I've kept the painting methods in both the model and in the view. So the Shape2400 class already has Shape2400. Here's Shape2400. Right at the end of the class, end of Shape2400. Here's the shape view. I can put multiple classes in one file just to make it a bit easier to find stuff. All my shape model views and controllers are in one file. So I've been calling them Shape2400s. It's the model. Here's the view. And here's the shape controller. The issue that you're seeing with that gray square was I have a paint method here, and technically right now I have a paint method here. When you're done with the code, when you're done refactoring everything, you're going to get rid of this, you're going to get rid of this, you're going to get rid of this. You're going to get rid of all of this when you finally refactored everything and you think it's working. You delete this and then you see if it works. Okay. Okay, let's have a quick look at, so Shape2400, here's what I'm doing. I have my paint outline goes to another class. My paint method also goes into a different class. But you'll notice when I need things like the, let's see a better example here. That's it because it's a Shape2400. Shape view, here we go. I will have a pointer to the model in my view. And so when I paint the outline, I say, well, first of all, if I don't have a model, stop what you're doing. Otherwise I say, hey model, are you selected? Okay. Hey model, give me the background color. Hey model, get me the rectangular bound for your shape. Hey model, give me this. Hey model, give me that. You're asking the model for information about what the shape looks like, and then you blindly draw it. Hey model, what color are you? Hey model, what is the background color? So this is just the dashed outline that you sometimes see on your when you draw things. Paint outline. I thought I had another. Paint. Oh, this is our generic paint. If there wasn't, it wasn't defined elsewhere. Okay, so you're also going to get rid of this function too. Okay, if we want to go to triangle.h, again, we have the triangle 2400, which is our model. And then down here, we have our triangle view. And all it handles is paint, but that's good enough. It's separating my concerns. Question is, do I need a controller? Do I need a triangle controller? I'm going to argue, what's the difference between the controllers for a generic shape and a triangle? There's no difference, really, right? You're just handling a mouse event, and you're checking to see if it intersects, which that's in the model. So you don't actually need a separate new kind of controller for each of the different shapes. You just need a controller. There are cases when you might need a separate controller for each of the shapes, but we're not in those situations. All the different shapes have the same kind of controller. They just handle mouse events. So you're going to pull out the paint methods from essentially from the rectangle and from the circle class. And you'll also need to modify your shape factory. So here is shape factory. Let's look at the CPP file version of it. Where is that thing? There we go. And by the way, I have an enumerated data type for the 3 different types of shapes. In case you wanted, if you wanted to add another shape on your own, you would just add a new type of shape here. Here's my shape factory. I can get the type of shape based off of the flags. So the flags are, I don't think you'll necessarily need to know that, but I'll point those out in a second. So it tells you what kind of shape you're drawing based off of shift or control. If you're shift or control pressed versus not having either of those keys pressed. And then we have a function for making a shape is a static function. As in, I don't have an instance of this factory. It is, I ask the class itself, hey, give me a shape, and it will give you a shape, a brand new shape each time. Okay. I have an endpoint, I have a start point, I have the flags for whether the control or shift is down, and the maximum size for the entire window, just in case the mouse points are wrong. Okay. So the canvas asks the factory to generate an object for it. It generates an object for it. When I've generated an object, it just puts in an array of different shapes, and when I go to redraw, I just blindly tell all the shapes to redraw. That's at least the theoretical underpinnings here. Every time I have a mouse event, I ask all the shapes, hey, is the mouse working on you or not? When I'm doing this model view controller thing, I need to separate it into views, controllers, and models. By the way, here is me using get type, right? I have a dword flags. This, by the way, is Microsoft giving me some set of flags, some values that were set, whether the control key was down or not. I would like to point out this. For those of you that did BIT1400 with me, and you said, what the hell's the point of learning bit flags and bitwise operators? There it is. They're all over the place. You just may not have seen them yet. This is saying if this particular bit at the force position in a binary number, we're seeing if that particular bit is on or off. If it is on, so the shift key has been pressed, then it's going to be a circle. If the control key was pressed, so if the bit flag let's see what bit it is, the 8 position on this on this big number, if the bit at 2 to the 3 position is on, then I'm saying it's a control, the control key has been pressed, and I'm going to make a triangle. Otherwise, if neither of those cases are true, I'm making a rectangle. Here's me making a shape. I get a start and end point. I find out the min and max values because it makes my life easier. So I just make sure that the min is actually the min, the max is actually the max. So no matter which way I draw this thing, I have the absolute minimum, the absolute maximum values. And then I'm going to, depending on what type it is, I'm going to make a, if it's a circle, then I'm going to make a circle and return it. If it's a triangle, I'm making a new triangle and returning it. If it's a rectangle, I'm making a new rectangle and returning it. What I'm going to need is to have a shape factory thing making views and making controllers. That's so. This is all the setup. I'm going to pause the video for a second because I think people's eyes are going to cross. When we come back next time, this is just the initial explanation of all the code. When we come back next time, I'm going to walk through how I'm going to refactor this canvas class to be a model view controller thing. And it's looking at it chunk by chunk, trying to figure out how I can pull out things that are related to the view. Okay, so hold on for a second, and we'll be back in a second. Take a break, think about how the code actually works, and then we'll get into it.